Hello friends and student. I am here again to represent the concept of non-ideal solution having positive deviation from the Raoults law. Okay. In previous video we have seen that depending upon the nature of the partial vapor pressure present in the solution, it is further divided into two types: positive deviation from the Raoults law, non-ideal solution having a positive deviation from the Raoults law, and non-ideal solution having a negative deviation from the Raoults law. Here we discuss a non-ideal solution having a positive deviation from the Raoults law. Okay. व्हेन द सोल्यूशन, हम ये जानेंगे कि सोल्यूशन कब, नॉन आइडियल सोल्यूशन कब आपको पॉजिटिव डेविएशन रिप्रेजेंट करेगा. ठीक है. फर्स्ट ऑफ ऑल, द इम्पॉर्टेंट कंडीशन, वी डिस्कस द इम्पॉर्टेंट कंडीशन. द इम्पॉर्टेंट कंडीशन which is responsible to represent positive deviation. Important condition which is responsible to represent positive deviation. First condition is partial vapor pressure of the given component is always equals to the product of the pure vapor pressure and mole fraction present in a solution. Second condition is the interaction between the solute and solvent molecule, means when we consider a two component named as A and B, then and after mixing with each other, when it form a solution, homogeneous mixture form a solution, then we see here, we have seen that in the case of the positive deviation, the interaction between the solute and solvent molecule, is always less than the interaction between the solute molecule and the solvent molecule. Okay. Second condition is the interaction between the solute and solvent molecule is always lower than the interaction between the solute molecule and solvent molecule. Okay. Third condition is the delta H mixing value is always higher as compared to 0. Okay. It means delta H mixing value is proceed toward the positive integral. Okay. The delta H mixing is always higher as compared to higher than 0. And fourth condition is delta V mixing is also higher, is also show the positive value, is also represent the positive value. Okay. First of all, the important condition, Raoults law. Then after we study that the interaction between the AB molecule, in the solute and solvent molecule, is higher as compared to the solute and solvent molecule, and delta H mixing is greater than 0, and delta V mixing is also greater than 0. Okay. For example, what are the examples for the for the positive deviation? The positive deviation is the solution will represent the positive deviation is the solution between the ethyl alcohol plus cyclohexane. Means when we prepare a solution of the two component ethyl alcohol and cyclohexane, it results the formation of a non-ideal solution representing a positive deviation from the Raoults law. And the Raoults law can also be studied with the help of following graph, or the non-ideal solution represent the positive deviation from the Raoults law can be studied with the help of following graph. Here we consider a 3 axis, 1, 2 and 3 axis. Same condition, this axis represent the mole fraction of the components This axis represent the vapor pressure of component 2, and this axis represents the vapor pressure of component 1. Okay, here we consider the component 1. The mole fraction of component 1 is 1 and mole fraction of component 2 is 0. Here we consider the mole fraction of component 1 is 0 and mole fraction of component 2 is 1. Okay, when we proceed toward the toward from x1 to x2, the mole fraction, the value of mole fraction of component 1 is decreases and the value of mole fraction of component 2 is increases. Okay, here when we consider that the component 1 is less volatile and when the component 2 is highly volatile, then their vapor pressure is also different from each other. The component 1 which is less volatile having a lower vapor pressure as compared to the component 2, because component 2 is the component 2 having a higher vapor pressure. Okay, is more volatile, therefore it is having a higher vapor pressure. Same condition according to the ideal solution, when it follow the Raoults law, it can be represented with the help of dotted line. Okay, here we represent the ideal behavior of the solution with the dotted line, and also explain in my previous video that how the value of these component can be calculated. When the solution represent the positive deviation, according to the positive deviation or the non-ideal solution, when represent the positive deviation, it's the interaction between the solute and solvent molecule is higher as compared to the solute and solvent. Therefore it represent higher value than the accepted value. Okay, it represents the higher value, therefore the graph will not follow the straight line, it follow this type of presentation. It follows this type of presentation of the graph. Okay, in same way this axis represent, it was the vapor pressure of component 1 and vapor pressure of component 2, pure vapor pressure of component 1 and 2. This axis represent the P total. P total means it is equals to the P1 plus P2. This axis represents the positive deviation from the Raoults law, means P partial vapor pressure of component 1 is higher as compared to the partial vapor, as compared to the accepted value, means it's represent more value as compared to the Raoults law. And this is for the component 2. This is for the component 2. P2 means P okay, it's having higher value, P not 1 x1. Okay, it is the graph, this is the graph which represents the non-ideal behavior, means positive deviation from the Raoults law. Okay, from in this video we have discussed the what is non-ideal solution, what are the important conditions for the non-ideal solution. Okay, here it is here represent the positive deviation from the Raoults law, it having a less interaction between the solute and solvent molecule, delta H mixing is not equals to 0, delta V mixing is not equals to 0, means it having a greater value than 0, and the example of ethyl alcohol plus cyclohexane is a the example of ethyl alcohol and cyclohexane is taken as a non-ideal solution having a positive deviation from the Raoults law. And from this graph we can study the behavior of non-ideal solution having a positive deviation from the Raoults law. It represents the higher value from the accepted value. Okay, thank you.